Well, welcome back, folks. Today we're going to continue on with the work on the disassembly and rebuilding of the Suzuki TS50 engine. First, there's a couple of things I wanted to share with you. One is that I've made a major decision after careful contemplation around the next steps for the Suzuki engine. You can see it's propped up right here on my left. Initially, I was thinking I was going to do a full rebuild. That is, I was going to split the cases and open it up and take a look at the bearings, etc., etc. But after reviewing the documentation and thinking it through, I've decided I'm not going to split the cases. I am going to replace the seals. All the seals are replaceable from the outside. That is, I don't have to get into the cases to replace the seals. I've taken a look at the bearings, I've spun the crankshaft, I've listened to it, it's nice and smooth. The transmission did always shift well. I never had any problem with the transmission. This bike has, at least on the odometer, around 1,500 miles on it. I have no reason to believe that that's not accurate because the speedometer is working. And given the relative condition, overall condition of the bike, I think that's probably an accurate figure, that 1,400 plus miles. So it doesn't have a lot of mileage on it. I have split dozens of engines in my life, and one thing I have learned, if you don't have to split them, don't. And since the transmission shifts fine, I believe the lower end bearings in both transmission and the crankshaft are fine, and we're going to talk about that more in a few minutes. Outside of replacing the seals, which are all still available, at least as far as I can tell from Suzuki, I can do what I need to do to this engine without, doing complete brain surgery on it. So I'm going to take that approach. One thing I did want to check was the play in the crankshaft, the big end bearing on the bottom, and there is a specification for that, though it's a little different than what I'm used to. But they do provide a specification here in the service manual that we've talked about a couple of times. And again, we'll get into that in some more detail in a minute. I'll take you through measuring the crankshaft big end or bottom end bearing play. And this, I'm happy to report this engine is well within factory specifications as supplied by Suzuki. So that supports my contention that I really don't need to split it. I don't think it's ever been split looking at the case screws, and we'll go ahead and replace the seals from the outside and not have to get inside the engine if we can avoid it. So we'll get to measuring the lower end bearing lash, I guess I will call it, or what they call, I think in the service manual, is play. We'll check that in a minute, and we'll have to switch to overhead camera to do that. Before we do that, though, I want to share with you how I bag and tag my parts as I do some disassembly. I want to share that with you. I've got some of them laid out here, and I'll switch camera perspectives, and we'll just briefly talk about how I bag and tag all my parts before I put them in storage, and then I'll pull them out later on, obviously, as we need them. So let's switch camera views, and we'll talk about part storage first, and then we'll come back. There's all the parts that I have removed from the engine so far. You can see them all arrayed here, already bagged and tagged. Tagged meaning they've been labeled. And over here you'll see the little bags, some of the little bags that I use to hold the parts. Now this isn't terribly sophisticated, I'll admit. I often will use the sandwich bags that you can buy in the supermarket or the grocery store. You can see a few of those over here on the left. But this is just an example. Let me grab these for you. You can see oil pump, I think you can probably read that, oil pump cover, left engine cover, right? I generally will make sure they're reasonably clean before I put them away, but I don't do the full cleaning until I go back to install them. Here's the clutch package we took apart in the last video. You can see the plates are right here. Here's the clutch basket itself, all zip tied together, and then I put both of those assemblies into one common bag. And then, miscellaneous right engine cover, those are obviously the screws, clutch push rod, kickstart, return spring, and hardware, oil pump, etc., etc. Let me see here. This is the one I want to talk about. These are the engine dowels hold the external cases on the engine, or align them rather. There's 3 on the right and 1 on the left, so I put them in their own respective bags. Not absolutely necessary, but I like to keep things separate but still together. That is, the left dowel is in its own bag, the right dowels are in their own bag, the originals. And then I label them, and then I just staple the 2 bags together. And then eventually these will all go into a plastic clear storage bin, which I have over here to the right. I'm not going to show that. It's just a clear plastic storage bin you can buy, again, in any dollar store, discount store, wherever. Buy them all over. Then the engine covers over there. The little plastic bags, let's talk about those. I commonly use 3 different size bags, and some of them you can see here. I buy these at a craft store. These are used often for jewelry, folks that make jewelry and sell it. Again, these are 3 different sizes. I think you can buy other sizes too, but these are the sizes that I usually buy. These are not expensive. You can get one of these packages for like $4 or $5 US, I think, and there's a lot of bags in there, folks. I mean, those will, just dropped one. Those will last a good long time. I only use the sandwich bags like you see here off to the left for larger components like you can see there. Hardware items, that is anything that's sharp or might poke its way through, I don't tend to use sandwich bags because I don't find them durable enough. That's why I use these jewelry bags here. They're pretty tough, they're inexpensive, they're easy to get. I do reuse bags also, by the way. Once I complete a project and I empty the bags out, if they're still in reasonably good shape, I will clean them and then store them, and I really will reuse them. Most of these bags are new right now because I was running out of good used bags. Most of them I threw away after the Honda SL125 project because they were getting worn, and I was concerned about their integrity, so I just threw them away and starting all over again. But I do try to reuse them if at all possible. This is a standard approach that I use on all my disassembly. I do this for everything, steering head bearings. Now the larger parts, like frame components, obviously you can't do this with, but as I go, I do a basic cleaning. I label the bag in a black marker, as you can see there, and package them up right away and then set them aside, and then they'll all go into that plastic storage bin I just talked about. So that's just a quick run through of how I bag and tag my parts as I take them apart. I don't get too far into the process without going back. For each assembly I'm working on, like the external side, part of the engine, clutch side here, the basket down here. I don't get too far into it before I stop, bag and tag, and get them organized before I keep moving on. Now we're going to switch back over to the engine. We're going to do an overhead shot. We're going to talk about measuring that big end connecting rod bearing, what actually Suzuki calls shake. S-H-A-K-E, shake. Is how they term it in the service manual. It's really the play in the connecting rod where it connects to the big end connects down to the crankshaft. We'll take a look at that. Here's my setup for measuring the crank shake, what they call shake. We'll get to the details of that in a moment. I have an imperial dial indicator set up here, mounted on a adjustable stand. This metal frame here that you're seeing part of is just my wheel balancer. It's steel, and that allows me to use the magnet on the indicator holder to clamp that down onto that steel base, so it's convenient and easy to use. The engine is just blocked up here so that I can get it level, and I've got everything lined up this way as well as center line of the crank. But before we go ahead and actually measure what they call the shake, here's the specifications from Suzuki, so I'm going to try to get this in the shot for you right here. We're talking about right here, number 6, crankshaft connecting rod small end shake. That'd be this diagram right here, 7.4, if you can see that. And the specifications from Suzuki is below or less than 3 millimeter or 120 thousandths of an imperial inch. So that's the target that we're looking for. And essentially what we're going to do is check the movement of the small end of the connecting rod right here. We're going to check for this kind of movement. That's what they call the shake. And as you can see, they're doing it here with the connecting rod removed, or the crankshaft rather removed, and set up on a couple of blocks, or bolted to a couple of blocks. But they're doing essentially the same thing that I'm going to do, only I'm doing it in situ, or installed in the engine. I have, well, let me zoom in here a little bit for you first, before we get to too many details. And I know right now there's glare on this dial. We'll fix that in a minute, but I did want to share with you my setup. Again, the engine's blocked up and level right now, or reasonably level. I have the connecting rod brought up a bit like this and resting on this piece of round bar stock that I had in my scrap box, just to get that connecting rod up in reasonably center line. I have the dial indicator dialed in pretty close right now. I'll finesse that in a minute. It's not quite zero, but I do have that dial indicator plunger on the center of the connecting rod, both this way vertically as well as this way horizontally. What I'm going to do is zero out this indicator. I'll pull this connecting rod all the way over to one side with my finger like that. I'll zero out the dial, and then we're going to measure that play or shake. So let me kill the lights here, and we're going to dial in 0 on the indicator. Let me zoom in a little bit for you. So you can see there I've got the connecting rod pulled off to the side. I've got tension on it with my finger at the lower part of the shot. I've got the indicator at 0. And again, what we're looking for on this particular indicator is no more than 120 thousandths, which would be all the way around one time, and then to 20 over here. That would be 120 thousandths. So one full sweep is 100 thousandths. So I'm going to now gently just push this over. We're at about 46 thousandths. I think you can probably see that okay. 46, 47 thousandths, which is well under the specification. That's about a third of the specification from Suzuki in terms of what they call shake. So that tells me that the lower end bearings at the bottom of the connecting rod, where it attaches to the crank itself, is okay and is well within Suzuki specifications in terms of shake. Now, the other measurement that Suzuki does provide is what they call the crankshaft shake, which is where you measure you put a dial indicator on the connecting rod, or rather on the crankshaft on one side or the other, like here, and you turn the crankshaft. So let me set up for that, and we'll give that a try as well and see how it measures. And I'll share with you the specifications on that. Now we're going to go ahead and measure crankshaft shake, and you can see the depiction here in this photo from the service manual. Suzuki has it set up in blocks, the crankshaft, got dial indicator here on each side. They do suggest measuring both sides. And the specifications for this, the crankshaft shake, if you can see that there, I hope you can, is 0.05 millimeter or below 20 thousandths of an inch. Since I'm using an imperial indicator, 20 thousandths is our target. Everything's set up now to measure this shake on the right end of the crankshaft. I still have that round stock, or that bar over here. I know you can't see it in the shot right now because I'm zoomed in and with the light turned on to avoid reflection. It's supporting the crankshaft just to keep it up on the center line so it doesn't flop around. I have my indicator zeroed out right now on the end of and centered and on the end of that crankshaft, just like Suzuki showed in the photo. And again, remember, the intention is not to exceed 20 thousandths of an inch. So I'm going to go ahead now and rotate the crankshaft, and you'll want to watch this indicator. We should be pretty much on the low spot. We'll see. It's about 3 thousandths right there. And just dip right there just a little bit. Again, about 3 thousandths. We're about 3.5 thousandths or so, I would say. Carefully turning it so I don't jar anything, which is well within Suzuki specifications, which again was 20 thousandths of an inch. So we have plenty of room to work with in terms of tolerance. Changed our setup a bit here, rotated the engine 90 degrees, repositioned the dial indicator to allow us to measure the left end of the crankshaft right here I'm pointing to at the bottom of the shot. Dial indicator is zeroed out. The rest of the setup is essentially the same that we talked about last time or a few minutes ago. And what we're looking for is no more than 20 thousandths fluctuation total on this indicator. Again, it's zeroed out right now. What I'm going to do now is just kill the light, and we'll go ahead and zoom in just a little bit so you can get a better look at the indicator as I rotate the crankshaft. So watch this indicator and we'll see where we end up. And I'm going to rotate the crankshaft as the engine would run, which is forward. You see that's what, about 4 thousandths of an inch or so? Yeah, about, there's the high spot. There's the low spot. So about 4 thousandths of an inch. So the right side was what, 3.5 thousandths. The left side is 4 thousandths. The specification is 20 thousandths. So we're well within. Based on all these measurements, the shake of the crankshaft, the shake of the connecting rod, general observations of when the engine ran, I didn't detect any noise from the lower end. Everything seems nice and tight. I don't get any noise out of the crankshaft when I rotate it. Transmission shifted fine. I'm not going to split this engine. I don't think I have to. I am going to clean it. I'm going to pull the oil pump off of here. Again, it's remounted temporarily. I'll pull the oil pump off, leave the oil lines, oil pump feed lines in place. I can replace the seals. Left crankshaft right here. There's the clutch push rod. I know you can't see these. Clutch push rod. Countershaft output sprocket right here. And then on the opposite side, of course, I've got the seal that goes into the rotor valve cover, etc. So there's seals on both sides. According to Suzuki, the parts diagrams on Partzilla, all those seals are available, and again I can replace them all from the outside without having to split the cases. I'm going to tank this engine now. After I remove the oil pump, I'm going to tank it and flush it really good in my parts cleaning tank. Then I will tilt it up and just let it drain dry, and I'll blow out the oil lines with some light compressed air. You don't want to overdo it, just lightly blow them out, make sure there's no residual parts cleaning solution. And let it dry out for a few days before I continue on with this. I do have a little cleanup of the crankshaft over here on the left side. I use a little light emery paper on that. But generally, I think she's just fine with new seals. The splines on the Kickstarter are fine. The splines on the shift shaft are fine, which would be other reasons you might have to open this engine up if you have to get it to replace the shafts. But again, remember, this engine only had 1,400 plus miles on it, and I do believe those are original, and I don't think this engine was abused, and I don't think it's ever been apart. So I think we're going to just leave it alone, clean it up good, put new seals in it, and move on to starting reassembly. At this point, I think we're going to call this video a wrap, folks. Any issues, questions, thoughts, drop me a note. Otherwise, as usual, thanks for watching.